Student, today we shall discuss about that what is the unit testing. It is a method of testing in which we test the individual unit of the source code. Means the source software is divided into different number of modules, and these modules are further divided into sub-modules, and finally at the bottom level, these divided into specific functions or a specific function which have a definite objectives. So in unit testing, we can check out the individual unit independently with other and it is related with the function correctness and completeness of the individual program unit. So typically it is written by the software developer, and the test unit testing case is written by the software developer. This is the important thing कि इसे आपको सॉफ्टवेयर डेवलपर लिखते हैं and the code needs its design and behave as intended. तो आपके जो यूनिट टेस्टिंग लिखे जाते हैं उसमें आपको डेवलपर लिखते हैं और वो पर्टिकुलर एक क्लास और ऑब्जेक्ट फंक्शन को ध्यान में रख करके ये टेस्ट केसेस को लिखते हैं. तो इसमें आपकी कोई भी फंक्शनैलिटी या कोई भी मॉड्यूल का टेस्ट जो होता है इंडिपेंडेंटली होता है, इंडिविजुअली होता है, ये करके होता है. ठीक है. यूनिट टेस्टिंग में हम लोग ये चेकआउट दैट व्हाट इज द फंक्शनल करेक्टनेस एंड कंप्लीटनेस. ये जो फंक्शन है क्या वो एग्जैक्टली बिहेव कर रहा है जो उसका इंटेंडेड ऑब्जेक्टिव था, और इसके अंदर हम लोग हो सकने वाली एरर्स उनको भी करेक्ट करते हैं, चेक करते हैं कि जो हम इनपुट दे रहे हैं और क्या हमें उसके रिस्पेक्ट में जो आउटपुट मिल रहा है वो सही है जिस इंटेंशन से आपने फंक्शन डिजाइन किया और जो आपने इनपुट दिया, तो whether you are getting the same expected output or not. So and if we are getting the output, whether the algorithm is giving you the performance as per standard or not. तो हम इसमें उसके optimizing algorithm उसके performance parameters को भी check करते हैं. We check out that the given function satisfy the requirement or not. Is there if there is also an error into it, we perform error handling during unit testing. And there are three ways in which unit testing can be done: the black box testing, the white box testing, and gray box testing. In black box testing, we simply give an input and we match the output that we get with the expected output. And in this way, we find this is kind of testing is called the black box testing. We are not interested in getting the detail, and we do not consider what are the internal detail of the particular module. So and here there are some application interface, internal module interface, and internal description when you perform the black box testing, because we are discussing about the internal details. And another one is the white box testing, in which you have the full information about what are the inside components and how they are designed, and then you check out the design structure of the program and every possible part of the program that should be tested, and every functionality and every task is tested in this. This is called the white box testing. The black box testing is generated by the client because he does not know the internal detail of the software, but black box testing, white box testing is done by the software developers. And another one is the gray box testing. In this, we focus on the important internal components, and we do the test like the black box testing, but for the some prominent features, we check out and consider the internal detail, and we check out the functionality of these core functions. So this is called the gray box testing. Here in this diagram, you will see that in the black box testing, we just give some requirement, and later on we test that whether the actual output is as per the required output or not. Depending upon this, we declare that the test was successful or not. In the white box testing, we completely understand analyze the structure of the software, and on the basis of the design or the architecture of the software, we design different test cases that test out that whether the internal functions or modules are working properly or not, and we design particular test cases for the individual path module separately, and finally we match the expected results with the final output. And the gray box is something in between the black box and white box. We consider the internal detail, but to a limited extent, and we can focus more on prominent functions only, and ignore the rest of the less significant one. And this is the hybrid of the black box and white box testing. In traditional testing, when we completely check the whole system, we do not test the individual system. In this way, it is quite possible there would be some error that could not be detected. And if we get some error, suppose after running a system, we find out that there are error in the system, but it would be difficult to find out where actually the error is if we do not perform the unit testing and we directly go for the integration testing and also system testing. So to identify and locate the point of error, we must have to perform the unit testing and unit testing. The traditional testing strategies are the print statement, use of debugger and debugger expressions, and test script. So these are the common traditional testing strategies: the print statement, use of debugger and debugger expression, and test script. In unit testing, each module is tested individually. The better we do the unit testing, the less effort we need at the time of integration testing or system testings. In this, we can find out what are the particular error in a module or segment part, and in doing unit testing, we at least test every segment at least one. So here, when we divide a system into smaller portion, it is better to test. And here we focus more on the objective of the particular function. And here the scope is smaller, or the particular function level we find which has a certain objective. It is easier to find out the error. And after doing the unit testing work properly, it needs less effort to perform the integration testing. The unit testing ideas. The unit testing ideas are: it should be isolatable, repeatable, automatable, easy to write. These, when you perform the unit testing, that should be done without considering the external variable or functions, and it should be done in isolation. And it should be repeatable, means whenever the system starts, these unit tests should be performed automatically, so that you need not to worry about whether these modules are performing well or not, performing as per expectation or not. So, and that these should be easy to write, so that it will be easy to check out every time whether they have any error or not. So the requirement of the unit testing is, or the purpose of unit testing is, to make the fast debugging, faster development, and better design. Because if you perform unit level testing, you need to design smaller functions and simple functions with cytometric complexity less than 10, and because of that, it is easy for development, and the design would be better than the random designs with different higher level of cytometric complexity and high values. And it is an excellent regression tool, because if you check out that if there are some, because of modification at some point, there are many other generating in the other module, then if you have performed the unit testing, it would be easier to handle all these things. And so it is an excellent regression tools, and it reduces the future cost as it reduces the cost of integration. So these are the benefits of the unit testing. The unit testing allows the programmer to reflect at a code later date and make sure the module still work correctly. So here you need not to check the complete system as a whole at a time, but you can check a part of it, and later on you can start checking the rest of the part. So in this way, you can refactor code at a later date and make sure modules still work correctly by testing the part of the program first. and then testing the sum of its part. Integrated testing become easier because you have tested the different component individually, so there is less possibility of error in these. Only at the integration level you need to modify the interface or some compatibility issues. So it is easier to perform integration testing when you are done with the proper unit testing. The unit testing provides a sort of living documentation to the system. And now the guidelines for the unit testing. First of all, it should be small and fast. And ideally, uh, keeping the test system small, development and the development the total time to execute will be smaller, so it would be faster and very cost effective also. So it would take less time, so it would be easier to retest or automatically test every time whenever there is a modification. So it should be small and fast, and unit test should be fully automated and non-interactive. Means it should be automatic so that user need not to take worry about that whether the software is working as per expected requirement or not, because every time we perform modification it should be checked automatically and it should generate if error if some kind of problem arises. And if more the manual inspection the test required, the poor the test case would be. So for the better unit tests, the code should be fully automated. Test cases should be fully automated, and make the unit test simple to run. Now configure the development environment so that single test suites can be run by a single command or a one button click, because the testing should be done in such a way that a simple person just by clicking at one part you can check the whole all the full coverage of the software, and it would be easy to handle and measure the test. After that, there should be the coverage analysis so that it is possible to read and investigate the point of error and which is executing and that is creating some problem. And we should not ignore that if there are some error in some part, we should stop working and we should first find out what is the cause of the problem, and we should fix that problem, and because we should not ignore any problem and that it is a small problem, but first we should fix that problem immediately. For that, all the unit tests should run automatically and successfully. And the testing level should be kept at unit level, because at this level we actually test classes, and there is a one test for every class, ordinary class, and the class behavior should be tested in isolations. And we should not focus on working the workflow process in a single pass. Because in this way there is a possibility that could create some error, because the workflow testing may have its place, but it is not unit testing. Workflow testing is not unit testing, and it may be unit testing must be set up independently, and no flow workflow should be considered as the unit testing, because it is done in isolation and no flow of work between different modules occur. And in the start, if you perform test, it is you should design the simple test. If the test is not simple, it is better that you do not design test cases, because if that will take very much long time. If you are writing the complex test cases, it will be very time consuming. So it is better to write small test cases and reduce the execution rate. For that, you need the simple execution environment and you need coverage analysis tool. it will improve the target class is part of the assembly and it can be accessed. Can keep the test independent and it should be maintained, though it would be easy to maintain and upgrade. And test cases should be written in such way it should not depend upon the order in which they are executed. The unit test should not depend upon the order. And the test cases name should be written as per the class name or the method name. Sorry, method test names. For example, if the test for the test save as class, and the test name should be test add listener test delete property, and means the each test method has one distinct feature and class being tested name and the name of the test method accordingly. Means if the name the method testing method as per the name of the class. Okay. The same thing is keep the test close to the class being tested. So the test case does not make any way to production library or executable. So this is important thing. Do not design test cases so that they get production access to the production libraries or executable. Next is the testing classes through the public API can be defined using the public API, and some testing tools make it possible to test private content of the class. But this should be avoided. Testing case should not access the private content because this would be harmful for the many project cases. But you may do this to improve the general design, not to aid testing. So, first of all, testing should be designed in such a way so that even the non-technical person who perform black box testing should understand that and he can test that. So think black box, and you should also think in the way of white box testing also, like the developer thinks, and also should write the classes which will test the program considering the architecture of the software. And you should focus on the more complicated part while testing, because these are the portions which generate maximum number of error. And you should also do not ignore the simple cases also. You should not focus only the complicated part also, but you should also consider the trivial or easy part also, because these things, if the error generated in those part, there will be major portion of error while the code start executing. And focus on execution coverage first. If you are, you should test out that whether all parameters or all portions of the code is running and all the functions are tested properly, not in the sequence, but we should design test cases focusing on the particular function, which kind of parameter it's saying and how it will be tested. So you should design test cases considering every functions and class and which kind of and you should pass parameter according to that, and you should design test cases as per the functions. You should also focus on the boundary value also. For example, you have designed test cases age calculating machine, and you should check out the boundary value like the 1st January or 29th February or 31st December, that whether it is calculating the correct age or not, or it is creating ambiguity or problem in that situation. You should, so your unit test cases should cover the boundary cases also. And these unit test cases should be designed for a by taking the input from the random number generator also, so you can so that the generation the generator should be like that it should produce value from the entire domain of each type. And test cases should test each feature at least once and even the ordinary code should be tested once. And use explicit asserts means the testing condition, like if A is equals to B. This kind of condition is more easier to change than just saying that the value is positive. So use explicit assert, because in this cases the testing performs better, shows better results. This kind of testing shows better results. And while designing, you should keep in mind that how the unit testing would be performed. So it would be better to design if you keep in your mind that how the code will be checked, and the testing is the way the testing is done. If you start write code considering that how it will be tested, then it will be better design. So you will generate better unit case also. And you should not write unit cases, testing cases, considering the predefined external resources, because it is done individually. And you should not prioritize the test, because unit testing is done in bottom-up manner. So you should not prioritize, because you will start from the bottom layer. So so priority should be put on the lower level first, because you are designing the least the module with the least priority at first. And you should also design test code for the possible failure. And if there is a failure, it does not mean that whole system is will have problem, but you should check rest of the portion also. The test cases can never prove the correctness of the code. They can only show that there is no error. So there are possibilities when the bug is reported, write the test to reproduce the bug. Because if you have found an error, then you should design a test case, and this should be assigned as a criteria for fixing that code. If this problem does not arise after modification, then it's okay. Then unit testing techniques are structural techniques, functional technique, and error-based techniques. So structural techniques are statement testing, branch testing, path testing, conditional testing, and expression testing. In statement testing, like now in statement testing, we execute every statement at least one. In branch testing, we check out that the branches at least one. In path testing, all the paths in the source code are tested at least one. In conditional testing, all the conditional testing are tested at least one. Okay. Now in the functional testing, this is like the black box testing, in which we just pass the value and we check out. So in the functional testing, we check out the input domain testing. With different type of domains are tested using the random number generator. The boundary values are tested. Now the syntax values tested. That this is the technique which is used to check the syntax of the application. And equivalence partitioning. This is a software testing technique that divides the input data of software unit into partition of data from which test cases can be derived. Means it divides input data into different classes. And last is the error-based technique. This is the technique because the person who has developed the code better understand the weak point at the point of the code. So this is technique is better when the developer is becomes the tester. So some error-based techniques are the fault seeding, mutation testing, and historical test data. In historical test data, when we have tested some portion test cases earlier, and we have found that these portions which generate more error then, or we have similar kind of problem, then it is a better to solve the code or as in the same way that we have used earlier to fix. And in mutation testing, this is done by mutating certain statement in our source code and checking if the test code is able to find the error. Because in it we just we change certain statement, and after that we test that whether the problem is arising or not. Because in the large expression, it creates generally some recursive effects. So mutation testing is very expensive because it needs a lot of modification at other places also. And false reading means so that some known defect are placed into the code and tested until they are all found. So we place some error, uh, generate some error into the code, and after that we perform unit testing and we find out all those errors. So that's all about this unit testing.